Greetings to everyone watching. I welcome you all to the last part of the calculus that is under differentiation. So today is the last day we are tackling the last part of differentiation. Then from there we will get to know more about integration. Remember, integration is the second part of calculus, immediately just after differentiation, which we are now summarizing. Now, the number 6, which today we are looking at, is the VV. The VV, which means very important terms. Remember, this one is now the backbone of differentiation, because this is where you will interact with the 10 marks question, and whatever I am about to tell you is what you will always come across in your exam. Now, here an examiner involves in the use of some special terms or some special words. When the following terms appear in any type of question with a function, be very keen not to mess up. Number 1 term, I don't know how should I write it. Okay, this way. Here are the four great terms, or the 4 important terms. The 4 great terms. You must not ignore this part. Number one, you will see something like momentarily at rest. Momentarily at rest, or maybe just momentarily alone. Now, when momentarily at rest appears in that question, what you should have in your mind is that equate velocity, in bracket, equate velocity to 0. Equate velocity to 0. Equate velocity to 0. When you just see momentarily at rest, equate velocity to 0. That is number 1. Number 2, maximum or minimum velocity. Maximum stroke minimum velocity. Maximum stroke minimum velocity. When you see this term, equate acceleration to 0. Equate acceleration. Equate acceleration to 0. Equate acceleration to 0. Number 3. When you see the word initial, an examiner must use either of those terms when this question is being set. Must, I promise you. Now, when you encounter the word initial, time is always 0. Time is always 0. When you encounter the word initial, time is always 0. Number 4, maximum displacement. Maximum displacement. Maximum displacement. Equate velocity. Equate velocity to 0. Equate velocity to 0 to obtain s, and s in this case is always distance. When you see the word maximum displacement, equate velocity to 0. Equate velocity to 0 to obtain s, and s means distance. Guys, that is the end of differentiation under calculus topic. When we meet next, we shall look at what is called integration. Remember, integration is the second part of calculus, just after differentiation. Integration. But I promise you, I shall look at various examples, so many examples under integration and differentiation, because when examiner will set this question, he or she will always combine both differentiation and integration. That is why I want us to tackle integration first. Then from there, we shall do more examples, because the kind of examples we are going to do, the kind of question we are going to do, will always be both integration and differentiation. Integration is very short, very much short, just like what? Just like differentiation. And today I don't want to take much of your time, but only to tell you that make sure you master these 4 terms, because without this knowledge in 4 terms, you are going nowhere with the calculus. You are wasting your time studying calculus. Whatever I've taught you previously, those are just but a minor parts of section A, which involves 3 to 4 marks. But now when you come to section B, the backbone of differentiation, the backbone of calculus, the backbone of integration is in this part, the very important terms, and the part of integration, which is also very short. I don't know if I should just do it, because I still have some more time. So you will excuse me. To just do it. Please, I beg. Now, let us look at this part. I may not get time to do it in another session, because it may take long, because I'll be going somewhere next week. So now let's tackle this integration. Now, I want you to be in a mood of like as if I'm in a new video. Don't be in a mood as if I was exiting the room. Now, concentrate. Integration. This is the reverse of differentiation. Just like a car can move forward, the car can also reverse. So you are being taught how to drive forward. At the same time, you will be taught how to reverse the car. Now, just like I've said, integration is the reverse of differentiation. Now, whenever integrating, the following should be taken keen note of. I want you to know this. Suppose dy over dx is equal to x power n. I hope up to this point, dy over dx, you know what is it? It is differentiation. Now, suppose dy over dx equals to dy over dx equals to x power n. Then, therefore, y is equal to x power n plus 1 all over n plus 1 plus c. Let me rewrite it clear. What am I saying? Suppose dy over dx equals to x power n, then therefore y is equal to x power n plus 1 all over n plus 1 plus c. Now, this is a formula that is there in every textbook that you will come across in Form 4 chapter. So, this is the formula that we shall apply when trying to solve integration question. And how will you know this? It is only a lot of questions that we shall do, more examples on various questions. Now, allow me to deal with this question in a manner that you will understand clearly. Okay, but before that, before we do those questions, you must know that 80% of integration questions are always curve. 80% of integration questions are always curves. What I'm trying to tell you is that when you are revising, know the kind of questions you are revising. Know the kind of questions you are tackling a lot. Know the kind of question you are exposing to yourself more. That is what I'm trying to tell you. 80% of integration questions are always curves. Now, there's this symbol, a symbol like S. This symbol, a symbol like S. This symbol will be used a lot and it refers to integration symbol. Now, when you see this symbol is a symbol of integration. This symbol is a symbol of integration. A symbol like S, it refers to integration. I'm always summarizing now. Both integration and differentiation both integration and differentiation are summarized as below by the formula by the formula. Both integration and differentiation are summarized as below by the formula. And which formula is that one? Siva. Siva. By the way, in mathematics, at some given point, you have to be less serious when you are trying to master some formulas, because it is by joke that some formulas will stick by you forever. Like, it has been around 1 year not doing mathematics, but I can still recall this subject very well. I can still recall the SVA, the SIVA formula. Now, when you are going up, that's why I've indicated some arrows here. When you are going up, you are integrating. So when you are going up, we integrate. Make sure you master this SIVA. Don't forget SIVA. When you are going up, you integrate. When you are going down, you differentiate. Differentiate. Up, integration. Down, differentiate. Now, when you are integrating, remember the formula. The formula for integrating is equal to y equals to x power n plus 1 all over n plus 1 plus c. Do not forget that one. Now, when you are differentiating, remember there is a formula for differentiating. Remember giving you that one in the very first place when we started. Dy over dx equals to x power what? X Naxnia. That is dy over dx equals to Naxnia. That is nax power n minus 1. Nax power n minus 1. I don't know how I'll write it very neat. Let me write it going slant way this way. Dy. Oh, sorry. It will be difficult. Now, let me just squeeze it. Dy over dx equals to Nax near. Yeah. But I hope you have that formula with you. So this is it. Going down, differentiate. Going up, you integrate. Just have it like that at this moment. Because the kind of question we shall come across, the kind of question we shall do a lot, will reveal a lot. To why I'm telling you, just have this at the moment. Okay. Coming to the end of this lesson, I want you to note, I may not be able to write it all, but note this. Any questions involving calculus and integration, if you come across through any of a question that is involving calculus and integration, make sure you write the above method or the above formula before reading the question or before attempting the question. There is a reason why I'm telling you this. Remember, this formula, for you to master it, for this formula to stick with you, anytime you are doing revision, you've come across a question on integration and differentiation, make sure you write this formula, everything the way it is, from the arrows drawn to the integrate and differentiate noted, and the formula beside them noted very much well. It is only by doing that with the several trials at several times of the day, you will master this formula and it will stick with you. And I'm telling you, this thing will help you a lot, especially when you are when you have an interest in pursuing a course related to mathematics. Maybe you wanna do BSc in BSc in mathematics. It will be very much like calculus is everything, is everything. So this one is bringing me to the end of this lesson. So whatever I've discussed last, that is the end of our lesson. I thank you all, and when we meet next time, I know it may take long, but I promise that when we meet next time, we shall do more questions on both integration and differentiation. For that, I thank you all, and may God bless you and shine your way in your academics journey. Just be positive, because nothing has ever been easy. Just trial, prayer, action. Everything will be fine. Thank you very much. I kindly request to get more subscribers. Talk with your friends, talk with your family, nieces, relatives, and it will be more pleasure to me getting more viewers and interacting with my channel and journeying together, learning mathematics together. I don't have much to add, but only to say thank you, and thank you very much.